harnessing the power of wind for electricity is a green technology that continues to grow and develop. Yet whenever wind farms are mentioned as a power-generating alternative, communities in the vicinity arc up about noise pollution created from these clean energy beasts. Enter the University of Adelaide. Associate Professor Con Doolan is heading up the Flow and Noise Group at the School of Mechanical Engineering to investigate what it is that makes the noise and how to curb it. He joins me on the line now. Con, good morning.
Good morning.
Now, what type of noise are we talking about? Is it similar to living in an apartment above a busy road, or is it a low hum?
Well, it's a good question, actually. It depends on how close you are to the turbines, because the atmosphere will, attenuate higher frequency sounds the further you get away from the turbine. So closer in, you can hear a swishing noise, and as you go further away, there's progressively more lower frequency components.
So you mentioned these lower frequencies. Is there a point that it can't be heard by humans?
Oh, eventually, yeah, the level gets too low to be perceived by humans, sure.
And so how close to the wind farms do people have to be for it to be hearable?
Well, that's another good question, because it depends on the size of the wind turbine and the atmospheric conditions and the wind direction. So it really needs to be worked out on a case-by-case basis. You can't really say that 1 kilometre, 5 kilometres is a certain limit.
I grew up in the mid-north of South Australia, where there's a whole bunch of wind farms happening near Jamestown and Burra and all of these kinds of towns, but they always seem to be in the middle of paddocks, which is away from houses or suburbia. Is this always the case?
Well, sometimes yes, sometimes no. There's noise guidelines that set the amount of noise that a resident can be exposed to, so that normally limits it to about 600 metres on average as the closest residence. But again, it always depends on the size of the turbine and the particular situation that they're in.
And so, in general, what problems can this noise cause?
Well, we can only go on what people say, their complaints. That they complain of a noise and an annoyance, and that's at one end of the scale. And other people complain of health effects, but we don't really know if there is a definite link between noise and health. That still needs to be determined.
And I've read about the placebo effect, in that people have been reading about these health effects and so have sort of attributed any health problems to the wind farms. Is this something that you've researched as well?
That's not really in our area, but with general noise annoyance problems, there has been some work that shows that personal moderating factors and the social situation that people are in can affect their sensitivity to noise, and they might become highly sensitized to a particular type of noise if they perceive that they're wronged by it. So in some cases, a source like a wind turbine, if they really don't like it, they may attribute all sorts of negative emotions towards it, and that will affect their noise sensitivity. So it's a complex issue.
I'm speaking with Associate Professor Con Doolan about wind farms and the noise they emit. Now, I hear you built your own small-scale wind farm. That's pretty cool. Now, what will this test?
Not yet.
Not yet?
We've just won a grant to build a wind tunnel model of a wind turbine. And so we're going to build a scaled version of it and put it in the university's large wind tunnel on the Thedberton campus, and try and understand all the physics behind all the different noise generation mechanisms. So
Adelaide Uni already has a wind tunnel.
Uh-huh.
That's very cool, but you're building a scale model so that you can test it with this small wind. So what will you be testing using this pretty cool machinery?
We'll be measuring the noise emitted by it, and we'll also be using laser-based flow diagnostics to understand the aerodynamics, so understanding the flow going into the turbine and around the tower, and also using arrays of microphones around the wind turbine to understand the noise coming from it.
It kind of seems logical that this should have happened before we put all these things, up. Have we seen experiments like this around the world?
There have been some experiments like this, and a couple in wind tunnels, but the one we've proposed is probably the most sophisticated one, where we're combining as much flow and noise measurement systems as knowing where the noise sources are coming from.
And I know you're sort of in the planning stages so far, but have you got any ideas on what might be the cause of this noise?
Oh, yeah, there's a few generally well-recognised mechanisms. One of them for the low-frequency components is probably due to turbulence in the atmosphere hitting the spinning blade. So as it passes through the blades, it can create low-frequency noise. And the turbulence as it passes over the blade surface is another source of noise. But we want to understand in more detail how it's doing it and what is the relative contribution to the overall noise. So what's the most important? And then if we understand that, we can try and control it and advise governments and industry on better policies for making wind farms.
So the next step will be to sort of work out how to stop or block this noise from happening.
That's right. Yeah, that's right, yeah.
And so if this project is successful, are we likely to see an increase in wind turbines here in Australia?
Well, I think they're coming anyway. I guess we really should be as best informed as we can be, so we can do it. Build these wind farms the smartest way we can, so we reduce the effect on those communities around them as much as possible.